on 33, and I meant to find the distance from a point to a line. And off the top of my head, I can't remember a formula for this, so I'm going to go back and rederive it from just thinking about the situation in general. If we're sitting out here in three-dimensional space, and there's some line out there, and I've got some point P. I want to find the distance from the point to the line. That is the length of this line segment that is from P to the line, and it is perpendicular to the line itself. Now, as I recall, if you know one other point, Q, I'll put that in blue. If you know Q, a point on that line, then you can come up with this guy, this vector right here, P to Q. The idea is to think about an angle between PQ and something else. Now let me think about it. Lines have directions, so let me attach a direction to that line in red. I will call him M. Okay. And I think I want to compare the direction of M to the direction of PQ, so I'll put another copy of M over here. M. And there's an angle between them which we could call theta. Okay, and now I'm meant to take the length of this line and find the length. Oh, I see. These three things, this line right here, and that line right there, made a right triangle. Ooh, unfortunately, this angle theta is not interior to that triangle, so let me finish off the triangle. I'm going to go back in blue. I'm going to take a copy of that line segment and put it over here. There you go. I think that's about the same length. And then I'll take a copy of this line segment, the distance from the point P to the point Q, this line segment here. I'm going to put that in right there. And now I see this also is a right angle, and this is the interior angle of a right triangle with sides of length, or the length of PQ. The length that I'm looking for, and I guess I don't care about this because I'm going to be dealing with an angle, the length of PQ, and the length of that side. Now, remember that PQ is meant to, let's see, PQ is that vector right there. Man, I drew an arrow. Now it looks like there's another vector. At any rate, PQ is meant to refer to that guy. So let's see. This is the opposite side. I'm looking for the length of the opposite side in this triangle, in this right triangle, opposite to the angle theta. So what should I do? I should name things. Okay, from the point P on to the line parameterized by 4, -2, 2t is, okay, let's see. I need a point Q. Okay, let's see. Is the let's see, you know what this is? This is a component of a directed line segment. Right, that's what I'm looking for. This right here is a component of the directed line segment PQ from P to some point on the line. Now let me choose a convenient point on the line. Oh, that's right, 0, 0, 0 is on the line, but maybe that's too easy. I'll use something else that's on the line just to make sure that I'm getting some exercise. Say 4, -2, 2, that's a point on the line, and let me call that Q. So the component of directed line segment from P to Q, I've chosen Q to be this, perpendicular 2 perpendicular to the direction of the line, which is 4, -2, 2. And which I'll define to be m. Okay, so let's see. That is, okay, so how do you get that length of that? That's the length of PQ times the sine of the angle in between PQ and M, and I'm going to call that theta for now. Oh, right, and you can get that from a cross product. Sine comes out of a cross product, so this is equal to the magnitude of PQ times the magnitude of the direction of M, of course, because that's 1 times sine theta. And that is the magnitude of PQ cross M hat. Or I could replace, instead of M hat, I could have M vector, and I could divide by the magnitude of M, so 1 over the magnitude of M. Good. And let me now run this calculation. I've got 1 over the magnitude of M. That is, the magnitude of M is 4 squared plus 2 squared plus 2 squared. So 16 plus 4 plus 4. 16 plus 4 is 20. It's 24. So I'm looking at the square root of 24. And then, sorry, that kind of, looking back at this, looks like a minus sign. So 1 over the square root of 24, that's the 1 over magnitude of M part. Then I've got the PQ cross M. Can I just try to get this straight away into IJK with a determinant looking structure? So let's see, what is PQ? P to Q, P to Q. So P to Q, you take Q minus P, 4 minus 0 is the first component, -2 minus 0. And 2 minus 12 is -10. And then we're crossing that with M, which is 4, -2, 2. Okay. And we're going to have to take the magnitude of that, by the way. Right? This is supposed to have a magnitude symbol around it, or the length symbol around it. And this right here, you know what? What do I have to do? Another one around here? 1 over square root of 24. Length of, let's see, -2 times 2 is -4, minus 12. -4 minus 12. Is that right? -4 minus 12 is -16 for the first component. Second component, 4 times 2 minus -10. So, okay, 4 times 2 plus 4 times 10. 4 times 2 is 8, and that's 40 to 48. And there's supposed to be a minus sign on there. You always put a minus sign on that middle component. Last component, 4 times -2, that's -8 minus -2 times 1. So -8, hey, wait a minute, 4, 2, 4, 2, oh, that just, oh man, that's just 0. And that, my friends, is 1 over square root of 24 times, on the numerator, let's just put that up there like this. We're going to have the magnitude of that 16 squared, those big numbers. 16 squared plus 48 squared plus 0 squared. Well, the spacing is ridiculous, but there we go. Maybe with some thought, I see that I could factor a 4 out of 24, I could factor a 4 out of 16 squared, and I could factor a 4 out of 48 squared. But hey, that would be some arithmetic stuff. I think I've done what I wanted to, and the rest of this is just, well, it's not algebra, it's just arithmetic.